Hello and welcome. Today we'll be going through the OptiAssist for Abaqus. This is tutorial 2, the composite ply shape optimization of a simple box beam. This example introduces a new laminate optimization method as well as the previous one shown with the thickness set data. This is ply subdivision, which allows a user to divide the existing plies into separate individual segments which can be analysed individually. As you can see, I've already loaded up the tutorial 2 and tutorial 2 optimize in Abaqus CAE with the original file in the left here and the updated one on the right. Similar to tutorial 1, the aim of the optimization is to reduce the initial displacement at the end of the box beam from 50 mm to 5 mm. Using the same scaling plot, this shows to be at 10% of the original optimization model. Using the same scaling plot legend, you can see that this optimization will be at 10% of what the original model was. To begin, if we go over to OptiAssist for Abaqus and click on Load Abaqus Input File, you will find the tutorial2.imp file under tutorial 2. Once that has loaded in, the first thing that you are going to do is under Thickness Set Data, click on New, and under Description we will name this set 0 to 30 plies. Similar to before in tutorial 1, where the min plies will be 0 and the max will be 30. Click OK, and with that highlighted, as well as the laminates, we'll click Assign Thickness Set Data, which has been added onto the laminates by the 1 underneath the thickness set. We will now go to Ply Pattern Subdivision Data, or we'll click on New, and we will name this one Subdivision, with a length in X to be 500, a length in Y to be 500, and length in Z to be 100. This will divide the box section along its own length in the Z direction at 100 mm intervals. Once you've done that, you can click OK. And again, with all the box laminates highlighted, as well as the new ply pattern subdivision data, we'll click Assign Subdivision, which you can see has been added on by the number 2 here. Once you have done that, we will click Next. No further ply linking is required, so again, we'll click Next. The goal for this optimization is the default minimized mass, so once that has been checked that it is there, you can click on Next. Under the Constraints tab, we'll click New and name this one Displacement, or DISP for short, changing the type to Displacement with an upper bound of 5 mm at node 521 at the end of the box beam. And click Create, and then click Next. Once you are happy with the solution type setup, we can click on Submit. Once the optimization has finished running, if we go back to your post-processor, in this case Abaqus CAE, and take a look at the new optimized model, which will be under tutorial 2 as the tutorial2_OPT, we can see that the maximum displacement is now 5 mm, 10% of the initial 50 mm and what was under our constraint. We can also take a look at the composite thickness results from the subdivision of the plies. This individually shows the new thicknesses of each individual ply at the sides and the top and bottom of the box beam. Each frame will be able to show you the individual laminate thickness separately. This concludes the tutorial.